So our next talk is going to be by Micah Cantor, who is a student at Grinnell College with an interest in compilers, functional programming, writing, and education. And he's going to talk about crafting interpreters in Typed Racket. Take it away, Micah.
Thanks, everybody, for sticking around for the last talk of the day. I know we left the best for last. Okay, so hi, I'm Micah. Like Sid said, I'm a student at Grinnell College. I'm in my last semester, and I think this is a fun, kind of circle back, because I was introduced to Racket in my first semester at Grinnell, not through how to design programs, but using Racket in that class. And yeah, I'm interested in functional programming and in compilers, in technical writing. Most recently, I lived in Paris over the summer. I worked for a French company called Tardes, and I worked on the OCaml compiler. But the project that I'm going to talk about today, most of it I actually did about 2 years ago. And it was the first compiler or interpreter project that I did. And it was my introduction to learning about that topic. So the talk is going to be about three things, mainly. The first is crafting interpreters in Typed Racket. So I'm going to talk about this really great book called Crafting Interpreters that I used to learn about Typed Racket and about interpreters simultaneously. The second part is some thoughts and experiences that I had with using Typed Racket for a compiler project, which were mostly positive. And the third part is about, when I was preparing for this talk, I was thinking about when I started, 2 years ago, I didn't know anything about language-oriented programming or about macros. I picked Racket because I had just used it in my class and I liked it. And I thought now, oh, am I a little loud? Okay. Is that working still? Hello? Okay. Sorry about that. What was I saying? Oh yeah, so I thought, would it be possible to take this, very traditional interpreter and kind of stuff it or morph it into a hash lang, and what would be the implications of that? Okay, so on to the first part. So the first question is, why crafting interpreters and why Typed Racket? So crafting interpreters, if you haven't heard of it, is a really great resource for learning about compilers. It's free online. But the provided code is written in Java. And I think if you're at this conference, you probably know why I didn't want to use Java. And I liked Racket, but I wanted the security of types. I was also, at the time, learning about Haskell and getting into typed functional programming, and I was more comfortable with Racket, so I thought I'd dive in with Typed Racket. So the overall design of the interpreter is, well, first of all, let's talk about what the language we're interpreting is. So the language that the book targets is called LOX. It's a dynamic, object-oriented programming language with closures, higher-order functions. And the first part of the book, which is what I did in Typed Racket, you implement a tree-walking interpreter and a handwritten parser. And so a lot of the talks already today have kind of talked about similar things, but essentially the way it works is we take the code, the LOX code, we parse it into an abstract syntax tree. So this is a very simple example of just 2 times 7 plus 3. It parses it into this binary tree in this case. And we evaluate it by walking down the tree and evaluating the left and right terms. So in here, we would evaluate the left subtree to 14 and the right subtree to 3, and then we add them together to get 17. Okay, so the interpreter pipeline is very standard. We start with the LOX code. We have a scanner and parser. We get an abstract syntax tree. We use a resolver to get rid of all of the variables, and then we evaluate that. So here, mainly, I'm going to be talking about the evaluator and not so much about the first two parts. Okay, so converting from Java to Typed Racket was interesting. I think some of the choices that I made. There's 3 main ingredients for this translation, as I saw it, or 3 main interesting parts. The first one is that Nystrom uses a design pattern called the visitor pattern, which is kind of a way of approximating or accomplishing the same thing as pattern matching in a object-oriented programming language. So we can get rid of that. It actually gets rid of a lot of code. We can just use pattern matching. The other thing is we can get rid of interfaces. So we're going to talk about a specific example where Nystrom uses a standard Java interface, and I changed that to sum types and pattern matching. And because I was trying to do a faithful translation, a lot of the code is imperative, and so I have some imperative helper macros. Okay, so pattern matching on expressions. If you haven't used pattern matching in Racket or in Typed Racket, it's really great. It's even better in Typed Racket because you can check the type safety at the same time. So here's like very standard evaluation function for like a binary expression, like the one in the abstract syntax tree that I was looking at before. So what it does is it takes in an interpreter object, which has some global state about the interpreter, and it takes a binary expression. It uses match define to deconstruct that expression. We evaluate the left subtree, we evaluate the right subtree, and then we do pattern matching on the type of the token. And so in this case, like, the token could be minus, in which case we'll check that the left and right are both numbers, and then we'll do the subtraction, and the same thing for multiplication. And like I said, we can get rid of the visitor pattern, and it's just much cleaner this way. So the next aspect is going from interfaces to pattern matching. So one of the main uses of interfaces in object-oriented programming is to implement the same functions for different types. And with sum types and pattern matching, we can do the same thing in a slightly different way. What we do is we provide different behavior for different cases of the same type. So what does that look like in practice? So there's a interface that's used in the book that's called callable. And the idea behind this is that there's several kinds of things in the LOX language that can be like called as a function. There's regular functions, there's native functions, and there's like class functions, like method calls. And all of these are called, but they have slightly different ways that they're called. So how do we convert that from an interface in Java, which we don't have in Typed Racket? Well, the answer is to use union types. So we can define a type called callable that's a union between function, native function, and class. And each of those function, native, and function and class are each structs themselves. And then we just do pattern matching on that union type. So in this case, we have a callable call function, which takes in some callee, we don't know which one it is, an interpreter and arguments, and then based on the kind of callable object that it does some slightly different things. Okay, super simple. The other kind of interesting translation aspect was with some imperative helper macros. So LOX is an imperative language, and a lot of the code is in an imperative style. So I wanted, especially in the parser, but also in the evaluator, to have just make it easier for myself to do some of this imperative code in Racket. So one of them, for example, is while loops. Maybe you've seen this before. It's very easy to define a very simple macro that is just a tail recursive function that evaluates a predicate and then evaluates the body if it's true. And one use of this, for example, is executing a while statement. So you can imagine a LOX while statement is just embedded directly into this macro where we just pattern match on the kind of while statement and then embed it. Okay, so the second part of this talk is about just some interesting aspects that I thought about using Typed Racket for this project. And Typed Racket, you may know, has good parts. I swear I didn't actually plan this before. So the three main aspects that I want to talk about that I really liked about Typed Racket in this project were, one, the migration and interoperability with Racket. Two, these polymorphic algebraic data types, which is a bit of a mouthful, but they're really awesome. And the third is the type inference. So the first one, the migration, if you haven't used Typed Racket before, it's really easy. Basically, you just change the lang to typed/racket. You add type signatures to the top-level functions, and it's basically about that easy. Most of the Racket standard library can be imported directly. And for other ones, they might be missing some type signatures, but it's easy enough to add them with a require/typed form, which can add type signatures to packages where you didn't write the function. The second great part about Typed Racket is these polymorphic algebraic data types. So algebraic data types are union and intersection types, I guess in the parlance of Typed Racket. And they make writing modular and composable types really easy. So we already saw like a small example of that with the interfaces and translating that to a union of structs. And I'll do another small example of that. The other part is polymorphism, which is type parameters, which make writing generic code that's type safe and really easy. So here's just another example of expressions as unions and intersections. So this is the full expression type. We're defining it as a union of all the kinds of expressions that it could be, like an assignment expression, a binary expression, et cetera. And then the structs, you could call them intersection types, are packaging all of the specific data to that kind of expression. And for all of these, just as kind of like a notational thing for myself, I liked doing define type to just alias the type name of the struct, because just to match the I guess convention of type names in Typed Racket. So the other area where polymorphism came up in this project was for having like a polymorphic stack data type. So this is used like in the resolver. We keep track of a stack of the scopes. And it's really nice because we don't have to, in Typed Racket, for instance, define like an int stack or an expression stack. We can just create a stack of A's like we would in other languages like Java. And it's really easy to work with. Here we define a struct that has a type parameter A. The data is a list of A and a size. And then we have a stack push and a stack pop. And I just want to point out the type signatures here rather than some of the more concrete signatures we saw before. In this case, they use the all form to say, like, OK, this is going to work over all types A. And it's going to be a function from a stack of A's to a particular A and return a void. OK. The last part that I want to talk about Typed Racket is about type inference. So Typed Racket can infer most of the types in expressions with very few annotations, except for at the top level. And so this makes it really easy to translate code that we would write in Racket like all the time into Typed Racket. So here, for example, we have this flexible length function, which takes in a string or a list. I'm doing that as a union of string or a list of anything. And in this case, with the if it determines that str or list is a string, then in the truthy case, it is inferred as a string, so the string length can run in a type-safe way. And in the falsy case, the same thing, but the opposite, with it's inferred to be a list, so we can run the regular length method on that. I'm not going to talk a ton about this, but just some of the frustrating parts that I ran into with Typed Racket. Slow compilation times. I ran into about 7 to 14 seconds for the 2,000 lines of code project versus the 2.5 second Nystrom's version in Java. There's some confusing and incomplete documentation in a couple parts, but overall the documentation is very good, but there was just a couple of parts that I didn't really understand. And editor integration with Racket Language Server, which is more of a Racket Language Server problem than a Typed Racket problem. But I'm a little particular about editors, and I liked using VS Code, but with Typed Racket, there's some friction there. But overall, it was a really great experience. OK, so the third part of this talk is going from a tree walking interpreter like this and converting it to a hash lang. So when I was preparing for this talk, I thought, okay, can I just take my tree walking interpreter and just stuff it into a hash lang? And would that be useful, or would that be good for anything? So the whole point of Racket is to create new programming languages, and that's what I did. But I just didn't use it using the kind of like marquee feature of Racket. And if I did convert it to a hash lang, I'd get some nice benefits. I'd get easier integration with other hash langs, like maybe I could import or require Racket code in my locks code and run them natively. Maybe I could get better integration with Dr. Racket, like in the interaction pane. And I'd get much easier packaging and distribution with Raco. So I thought this would be cool. And the answer is yes, you can do it. But it's a little tricky, mostly because of just kind of like the documentation and resources that are out there for how to create a hash lang. They're not really targeted at people who already have a programming language in Racket. Their audience is more for people who know how to use the macro system in Racket and want to create a domain-specific language. And so there's just a little bit of friction there. And the other part is some of the parts of your interpreter might have to be redesigned, moved around, or refactored, really to make a useful hash lang. So just what I'm talking about with documentation, this was the first place that I went when I wanted to create a hash lang. And I've worked on a professional compiler, and from the beginning, I was kind of lost. And that's not to say that documentation is bad. It's really thorough, but it's just targeted at a different audience than I was coming from. It wasn't targeted at somebody who was trying to convert their existing compiler into a hash lang. So the other resource that I went to was Beautiful Racket, which does a great job at demonstrating from very simple steps to more complicated programs how to create a hash lang. But after using it, I really came away with that just like hash langs are just weird in comparison to traditional interpreters. They use like the macro system as the main way to expand and evaluate, and it's just a different structure than I was coming from traditional interpreters, and there wasn't like a really great entry point for how to go from one paradigm to the other. But it's actually pretty easy. There's not a lot that you have to do to take your existing interpreter and convert it into a hash lang. We just need to create a reader and an expander for our existing, using our existing compiler pipeline interface. So the reader is going to convert from lock syntax to S expressions, and we're basically going to use our parser and just plop it in. And then the expander is going to evaluate those S expressions, and we're just going to use our existing interpreter to do that. So this is the whole reader. All we have to do is create our parser and scanner. So that's the make scanner. We run the scanner and get a stream of tokens. We run the parser, and we get a list of statements. And then all we have to do is plop those statements into a module and specify that we should use the locks expander. And then the expander is similarly simple. All we have to do is set up the interpreter. So we create the interpreter, we create the resolver. We have a small macro for how to run a list of statements. So in this case, first, before we run anything, we just check if there was a parser error, in which case we're not going to generate anything. Then we run the resolver, and we check if there was a resolver error, and then we run the interpreter on the statements. And then finally, we just need to define the module begin for laying locks. Sorry. And in this case, all the module begin is going to do is going to take in a list of statements, and it's going to run, just going to run them, and then pass them over to the regular module begin. And that's it. We can now run locks programs as a laying locks. So here's a hello world example. It's very much a proof of concept, better integration with the rest of Racket would require more work. For example, we could rebind hash %app so that you could actually run Racket functions. We could add in support for require, so you could require other Racket functions. We could do things with top interaction so that you can get REPL working with locks expressions. But really, this is the basic framework that I kind of came away with. So some concluding thoughts. First, Typed Racket is great for writing traditional interpreters. And second, there's definitely room to improve the communication on how to create a hashling for experienced compiler writers. I think like Racket's paradigm is really cool and really interesting. And I think it is accessible to people who already have some knowledge of interpreters, but maybe just the resources aren't there right now. So, yeah. Thank you so much. I just want to mention I'm graduating this semester. I'm looking for a job right now. And I also have some cool Racket stickers that were printed a couple years ago at Grinnell. They say, "That's right, I do Racket science." So I have a stack of these. They're the last remaining ones on Earth. So if you want one.
Should give them to people who ask questions.
Yeah. I have 16, I think. So
let's start those questions then.
Yeah. Thank you.
So I understand this is a translation of like an interpreter translated also from a book. Mm-hmm. But in the future, if you were to implement a new hashlang from scratch, mm-hmm. would you choose to do this interpreter method or an expansion to like Racket forms?
So the question was if I kind of were doing this again or doing this in the future, whether I would take the traditional interpreter approach or take the hashlang approach from the beginning. I think if I was really set on doing it in Racket, and now I know more about hashlangs, I would kind of try to do it using the hashlang paradigm because it makes everything else like a lot easier if you want to have tighter integration with Racket. And what I saw when I was trying to convert this to a hashlang, there's just, if I wanted to really get better integration, there's probably just things that I have to like turn inside out or refactor, and it would just be more work. That being said, like, I think the traditional method, there's just, there's a wealth of resources on how to do it. And so maybe if I'm, really leaning on those, then I would go for that instead.
Sticker. You want to give her a sticker?
Oh, yeah.
You gotta ask a question.
Hi. I'm Sarawi, also known by the name Oak. So what feature of Typed Racket do you wish to exist, but maybe it doesn't have? For example, I see that you use pattern matching to deal with the interface, right? Mm-hmm. But I believe Racket has generic interface, mm-hmm. but I don't think that's kind of like implemented in Typed Racket yet. Mm-hmm. That's my understanding. If we have that, would you find it like much easier to work with?
Sorry, I didn't hear exactly what you said. If they implemented what?
If Typed Racket has like this generic interface as well.
Okay, yeah.
Would you use it, or like would you find it much easier to do what you were working on?
I think for this specific example, I didn't need anything more because if you think about it, the callable interface is like a finite interface. There's only going to be a finite number of different ways that things can be called in a programming language. A lot of other interfaces are much more flexible than that. Like I'm thinking of like an iterable interface. That one, there's like users could provide like a lot more kinds of data structures that are iterable. And so for those cases, having just a union is pretty restricting because you have to define in the type, like these are all of the cases that it can be. So yeah, I think something like that. I don't know what the proposal for those are exactly, but something similar also to like type classes in Haskell or traits in Rust. I really like that feature. doesn't have to be super complicated like Haskell's type classes, but more on the simpler side. Yeah. Oh yeah, go ahead.
Thank you.
Yeah.
Did you try and equip your hashling with Dr. Racket's like arrows support?
Did I try the what? Sorry.
Try and equip your hashling so that when you bring it up in Dr. Racket, like Dr. Racket understands the binding structure of your language.
I'm not sure I understand exactly.
Okay.
Yeah.
I was just curious. There's
Yeah.
a fancy feature in Dr. Racket where it's meant to, you hover over a variable. It's meant to show you what it's bound to.
Yeah, it would not do that right now. I think there is a way to like extricate the environment from the interpreter and hook it up into Dr. Racket. And that's part of there's much more that you could do. I really was going for like the bare bones hashling implementation of like, I have this interpreter already. Can I just stuff it into a hashling? But yeah, I think there's a lot more things that I could do like that, or like the interaction pane. Thanks.
Sticker.
I want a sticker. Yeah.
Oh yeah. There you go. Yeah.
We have an online question. Could you see Julia-style multiple dispatch being implemented using these mechanisms, assuming you are aware of that language?
I've heard of Julia, but I don't know what its multiple dispatch looks like. So maybe there's somebody in the audience who could answer that better. But
No takers. Okay, we'll move on to the next question.
Howdy, I'm Matthew. Several of the pain points that you touched on for Typed Racket was around documentation. Do you have any plans to contribute to documentation with things that you've learned?
You're really putting me on the spot here. Yeah, I should get around to that. I think so. Yeah, that'll be tonight's project. No, I'm kidding.
Sweet. Appreciate it, because I'll need that at some
Yeah,
point.
thanks.
Can I have a sticker?
Did you have a question?
You just want a sticker.
Oh, you just
That's okay. Okay.
take a sticker.
You can still have a sticker. Yeah.
Yeah. All right, any non-loophole questions? Well, no, I guess that's it then. Let's give it up for Micah.